Hi everyone, I'm Kathy Zip, Managing Editor of Solar Power World, and I'd like to welcome you to today's webinar, Whose Side Are You On? Microinverters versus Power Optimizers. I'd also like to thank UpSolar and SolarBridge Technologies for sponsoring this webinar. Before we begin, we'll go over a few house cleaning items. I'd like to mention that this webinar will be available after the presentation on solarpowerworldonline.com, and it also will be emailed to all registrants, so you'll be able to view it again at your own convenience. Secondly, there will be a question and answer session at the end of all the presentations. This is a great way to pick our presenters' brains, so we encourage you to participate. You can do so by submitting your questions whenever they come to mind at any time by typing them into the GoToMeeting panel on your right. And lastly, we encourage everyone to tweet about key topics and discuss takeaways using the Twitter hashtag SolarWebinar. And at this time, I'd like to introduce our excellent panel of presenters. Today, we're thrilled to have Sunny Ray, VP of Renewables at Intertech Testing and Certification Labs, Pete Mornings of Bristol, Tennessee Solar Installer Ecological Energy Systems, and Kevin Lampo of Lancaster, Pennsylvania Solar Installer Sunline Energy Systems. Again, we're so glad to have you all with us. Looking at microinverters versus power optimizers is a topic that I've been eager to learn more about, and by the looks of today's turnout, I'd say our listeners are too. So we'll begin learning with Sunny Ray, who will be our first presenter. Sunny Ray is the Regional Vice President for Renewable Energy at Intertech, providing direction for the photovoltaic, wind, smart grid, and semiconductor businesses. Sunny has been with Intertech for 25 years, and during that time, he has helped solar manufacturers and users establish product safety and global regulatory compliance programs. He was also instrumental in establishing Intertech as a key player in the photovoltaic industry, with laboratories in Lake Forest and San Francisco, California, and Shanghai, China. He is recognized as an international expert in solar testing and certification, with several published articles and industry presentations to his credit. So we're very thrilled to have him here with us today to share his expertise. And Sunny, we'll go to your presentation here, and you can begin whenever you're ready.
Great, thank you. So as Kathy said, I'm with Intertech, and I want to give you a quick overview before I get started with my presentation, a couple of quick slides on Intertech. Also the fact that I'm going to be speaking on the regulatory compliance topic, which is common to both microinverters and optimizers before we start diving into the differences and advantages of one over the other. Just to give you a quick overview, Intertech, you're all must be very familiar with our ETL certification label, which is the group that was founded by Thomas Edison back in 1896. So that's how far back our history goes, doing product testing and certifications. Since then, we have grown into a group of over 1,000 laboratories and 36,000 plus employees in 100 plus countries. We are traded on the London Stock Exchange. We're part of the FTSE 100 companies there with a market cap of over £5.5 billion, which is anywhere from $7.5, $8.5 billion with the conversion rate. So moving forward, so that's how big our structure is, but I want to start talking to you about the microinverters and the optimizers from a regulatory compliance perspective. There are specific certification requirements for both of those products, but in most cases they're not. They're considered very much equivalent when it comes to the certification standards. The standards that are most commonly applicable to both products in the U.S. is the UL 1741. In some very rare cases where a microinverter or any other inverter, but if we're talking about microinverters here today, has any connection with the grid, it also needs to meet the IEEE 1547 requirements. For Europe, the standards that the product needs to meet is the IEC 62109, which is also the standard that's commonly used in the rest of the world. So IEC standards, as most of us know, are considered the more global, more international, and those so 62109 would be something you'll have to consider it to make before you could take the optimizers or the microinverters to the market globally, and 1741 in the U.S. There are some additional regional requirements. In a lot of cases, those are related to the rebates, the feed-in tariffs, the local benefits that certain states and certain regions provide to the solar industry. So I'm just using CEC being in California myself as an example. That California Energy Commission requirements is something that might be over and above the 1741 requirements or the 62109 that product needs to meet. Moving forward, just to give you a quick overview, what these standards really require the products to meet. Giving you some examples of the tests that you have to meet, very just like any other standard safety standard. Dielectric test is a very common requirement that every product has to meet. There are specific requirements for output overloads on these products. There are specific requirements on short circuiting, load transfers, loss of control, a reduction of spacing, and as most of these products are installed outdoors, in a lot of cases, there are specific requirements for rain and sprinkler tests as well. Not spending a lot of time on 1547 because not too many products are connected to the grid in this case, but the 62109 also look at over and above the 1741 requirements, also look at some single fault conditions, some humidity conditioning, and some physical tests like there are impact tests, drop tests, short circuit tests, and things of that nature. So those are some of the tests that are required by these standards. Sorry about that. A little delay in moving the slides. The AC modules, where the module is attached to the microinverter is attached to the module, there are some additional requirements that you might have to meet, which are specific when the microinverter is attached to the module, is more considered as an AC module, and there are specific requirements within 1741 for the AC modules that have to be met, and then the additional requirements with respect to the exposure of the DC cable, the grounding of the inverters, and things of that nature. Anywhere where certain additional circuitry is added into the junction box or into any other hardware within the solar module, we commonly in the certification world like to refer to them as the smart modules. And in that case, there are specific requirements on the change to the PV module that you have to meet, like in the case of a junction box change, specific requirements that are related to 1703 that are in there. And then if that additional electronics or the change junction box was secured to the module with some type of an adhesive or something, then you're looking at having to repeat some of the conditioning tests that most of the modules have to go through during a 1703 certification. For example, I've mentioned here the HF, the humidity freeze test, or the temperature conditioning test, which is a 200 cycle test, where the modules are cycled from minus 45 degrees C to plus 85 degrees C. So you're looking at having to repeat some of those tests when you're physically attaching these microinverters or the optimizers to the previously certified modules. And there are additional requirements for grounding as well. When you attach these, instead of attaching it to the back sheet of the module, if you were attaching it to the frame, or if you're attaching it to the racking system, then you're looking at additional grounding requirements. Real quick before I wrap up on the requirements, certain devices have communication electronics that's included into these, whether it's wired or wireless. There are specific regulatory requirements you also have to consider, like, you know, if there's any kind of a microprocessor control within the system, then you're looking to having to meet the 60950 requirements in the US as well as in Europe, and the low voltage directive and EMC directive requirements for selling these products in Europe. If you have a wireless communicator that is within your microinverter or in your optimizer, then you're also looking to meet the FCC-related requirements, because now you become an intentional radiator of radio frequency, and there are specific requirements for that as well. Moving forward, as I mentioned already, for Europe, there's not a specific standard that's harmonized within all the countries, but there are certain country deviations within the 62109 standard that I mentioned earlier that's really used in the rest of the world outside of North America. But you also have to be aware of certain country deviations that might be there for going into China or Japan or Australia or India or any of the other countries, but 62109 is your base standard. For Canada, there is not a specific standard that's, you know, as you all know, the regulatory standards tend to lag technology by 6 months to a year, sometimes several years. So it's really necessary that, you know, your product, in order for you to sell the product there, that you use a combination of different standards that address all the safety, all the regulatory aspect of your product. So in Canada or in the rest of the world where there is not a specific standard that refers to the microinverters or to the optimizers, you need to look at using a combination of standards to address all safety aspects of that product. So moving forward, really wrapping it up from my perspective, from regulatory perspective, being a global certification body, you know, testing products for, as Kathy mentioned in the beginning, personally been involved in these over 25 years at Intertek. My recommendation for you to, before you take the product to the market and have it certified and meeting all the regulatory requirements, is to really start early during the design cycle and not wait before you're ready to take the product to the market. To make sure you're avoiding the costly retrofits later, really designing the regulatory requirements in the product versus it being an afterthought or trying to add those later. One of the biggest non-compliance we noticed during the evaluation process, the certification process of any renewable energy products is components. A lot of the people use components that are custom built for a certain product, or components that might be a few cents cheaper because they don't carry a lot of the regulatory certifications, is to select components that have global certifications for the components already completed before you put them together and build your optimizer or build your microinverter. Always consider the installation. How you're going to install it, where you're going to install, what regulatory issues are going to come in when you install your components or your product, whether you want to attach it to the frame or you want to attach it to the back sheet of the modules, or you just want to attach it to the racking system. Each one of them, as I mentioned in the last few slides, bring in different sets of requirements. So understand how that's going to impact your regulatory compliance issues and how it would add additional testing and certification requirements. One of the key things is taking advantage of the overlap between all these standards. Whether it's an IEC standard or an ANSI standard in the US, or commonly known as UL standards, or the JET standards from Europe, or the Chinese national standards, the basic requirements are very similar between them. So if you were to work with a testing organization that had certification or accreditations in each one of those regions, they can really help you take advantage of the overlap between all those requirements. So when you're designing your product or targeting certain markets, make sure you're not trying to piecemeal that, because that could get very costly. It could require a lot of retrofits and a lot of repetition of tests. If you decide on your target markets and go for compliance and meeting those requirements at the same time, there's a significant time and cost saving by taking advantage of the overlap between all these standards. So just at the end, I wanted to give you my contact information. If there are any questions right now, I'd be happy to answer those. Or if you wanted to send those questions through Kathy and others, be happy to help you guys with that as well.
All right, thank you so much, Sunny. And yes, if you have any questions, feel free to enter them right now. We'll ask them all at the end of all the presentations. So next we have up our next presenter, Pete Mornings of Bristol, Tennessee, solar installer, ecological energy systems. Pete has been working with clients providing site and financial analysis since the company was founded in 2009. Having an extensive background in installing industrial electrical equipment, Pete is passionate about applying this knowledge in the renewable energy field. He has also owned and managed a contracting company for more than 15 years and is a licensed building contractor. He has had thorough training and experience with installing solar, geothermal, and wind energy. So we're very happy to have him with us to share his knowledge and expertise. And Pete, just go ahead whenever you're ready.
Thank you, Kathy. Are you going to put my slide up? Or
yes, it should be coming up right now.
There we go.
There you go.
Yeah, my name is Pete Mornings. I'm with Ecological Energy Systems here in Bristol, Tennessee. We've been installing solar now for roughly 3 years. We have a small storefront here in Bristol on a busy road, and we've installed a little bit over 600 kW in capacity already, and continue to have a healthy pipeline in the works as well. Let's see here. We market through community engagement, and education. We do lunch and learns for businesses, cocktail hours for homeowners, and sponsor events as well in the community. The AC panel is one of our most popular that we've had. We've installed both microinverters and AC panels. What we like about the AC panels is that they're attached to the panel at the factory, which eliminates the grounding of doing the microinverters and the panel separately. They convert the DC power to AC right there on the panel, and it makes a much quicker installation. This is a dairy barn that we recently completed, a 50 kW system, 208 panels. This system from day one to finish was 5 days. The panels actually were installed in one day. This is a residence in Watauga, Tennessee. They went with the microinverters. This installation actually offsets the complete electric bill of this residence. This is a governmental ground mount situation that we did in Abingdon, Virginia, and they actually demanded the microinverters because of the research they had done on the inverters. This is one we're very proud of. This is a 50 kW outdoor educational pavilion we did for Holston View Elementary School here in Bristol, Tennessee. You can see the last event that they had a little bit over 400 students out there under the pavilion. And this installation is actually up for Project of the Year on Solar Building Magazine. You can see the link there at the bottom of this slide. The microinverters are easy, but the AC is much easier with the installation time and the monitoring that is available with it as well. The last 8 of our 12 projects have been with AC panels. The cost benefit of the AC panels versus the DC systems, currently we're selling the 10 kW DC systems for about $35,000, and you can see the AC system is only about $1,000 more expensive. The AC panels are pretty much plug and play. You have no PV wire or anything like that to worry about. The module that we've been using lately is a MAGE panel with the attached AC solar bridge inverter, and both are covered with the 30-year warranty. If anything happens to either, both get replaced. And here's my contact information. If anybody has any questions, feel free to call me. Thank you.
All right, thanks, Pete. Thank you for all the insight. We appreciate it. And we'll get some more insight on the power optimizer front from our last presenter, Kevin Lampo of Lancaster, Pennsylvania, solar installer, Sunline Energy Systems. Kevin got his start with low voltage DC for yachts 10 years ago as he installed wind generators and PV panels to outfit navigation and electromechanical systems. From there, he moved to off-grid design and implementation for customer applications, and he joined Sunline 4 years ago to branch into grid-tied and battery backup systems. There he developed unique design and operation systems to maximize purchasing power while minimizing costs in the field. This capability has allowed Sunline to stay competitive against increasing pressures due to natural gas exploration within the Mid-Atlantic region. So we're very excited to have Kevin here with us today. And go ahead whenever you're ready, Kevin.
Okay. All right, let's see if I got, there we go. Okay, so, and let's try that. Okay, so for Sunline, the real question came to what technology could we apply to the cost reduction cycle to over the next few years to really be able to compete. And so I want to break the threats to the industry down to the controllable and the uncontrollable. The controllable threats are cost to relative to the grid, things like levelized cost of energy on PV versus the grid costs, especially the costs that natural gas or the pressures natural gas are applying to the Mid-Atlantic and Northeast region. Some of the other controllable costs are costs that code and standard bodies add to it, but those are things that we can see a mile down the road, and if we're smart, we can step aside of them, although others still let them run right over them. And then the cost of doing business, which seems to be the hot topic of the last couple of years of reducing acquisition costs and some other soft costs. Some of the uncontrollables are, force majeure threats, and those are geopolitical environment. And then the raw price of material. We can't really control the cost of copper or silver, but we can control, how much we use. But the commodity price is kind of fixed. So When we talk about smart reduction costs, again, we can't control the cost of copper. We can control how much we use in a given system. Balanced system costs, both real and imaginary. Real costs are things you can count in a warehouse. Imaginary balanced system costs are things like labor and acquisition costs, marketing costs, sales costs, warranty and service, and so on. Labor efficiency is another place. Now, I'm not talking cheaper labor. I'm talking about more efficient labor, and I'll get into more of that. And then long-term warranty, how much you put in reserves for long-term warranty, and what you can do to combat that number. So let's first talk about the finite limit to module level costs. Per panel cost, or cost per panel, should always be something that you look at. We in the industry talk a lot about price per watt, but really when you look at a price per panel, there's some glaringly obvious things that the industry needs to work to kind of better compete against pressures of the grid. Hey, Heather. I don't want to like totally take over your computer.
Yep. All right. We're having a technical problem. Here we go. Sorry about that. I'll fix.
That's all right. Apple decided it was time. Okay. So so when we look at per panel costs, one of the trends we've seen here in the last few years is the gradual increase in both panel dimensions and the wattage output. So rarely do we see 54 cell panels. The installers kind of bemoan those days because those were nice and light. Now we're seeing 60 cell and a lot of 72 cell coming in. We're also seeing that the efficiencies both in cell output and manufacturing technologies have helped to increase the output of a given size panel. And that leads to scalability of technology and progression of technology questions. And these are things that we are not too impressed with what the microinverter camp has been able to do. In fact, we're starting to see spin on the upper level 60 cell panels where they say, well, it's only going to output like 240, but you're only shaving this little bit off here and this little bit off here, and it's not that big of a deal if our shortcomings are manifest through your customers. So we're already starting to see some trips with the bulk of the microinverter groups where they can't keep up with the output of panels. The other piece that is very obvious is removing of components. We see in the AC panel products that are out there, they're still full-on J boxes. Some of them have cropped their wires. Some of them are still keeping full-on panel dimension wires. Connectors, these are all waste of money. They don't have to exist. We're starting to see some low-profile junction boxes, but the junction box is still integral to an AC panel. With smart modules that have come on the scene here in the last year or so, a lot of those components have gone away. Not to mention the internal bits and pieces that are within each technology. There's far less components in an optimizer versus a microinverter. So another trend that we see here, and it's kind of been the topic for this year, is these string level three-phase inverters. Many of the inverter manufacturers have decided that, hey, we can make more money if we sell more units that are smaller because it's easier for them to manufacture. Unfortunately, it drives cost in the wrong direction. It increases balance system costs, increases labor, and it's a bad precedent for the industry to set. It also sets what I'll call a dangerous mindset, which is that customers will start perceiving small string level inverters as safer when the industry needs to then transition to larger central inverters. It's going to get themselves stuck where the customer is unwilling to go along with what is necessary to bring costs down to better compete against the cost of grid power. So we move on to labor, and it's not cheaper and quicker, it's smoother and better. So when we talk about labor savings, the conversation should be about planning and standard operating procedures, should be using better material systems. You don't buy a clamp, you buy a racking system, and those systems should be ones that flow very naturally through your company. Lower part counts are big because they help in allowing for fewer systems to train on. You know, with a microinverter, you know, very few companies are only going to look at the small end of the market. They're going to want to install 2 panels to 20,000 panels. And in that spread, you're going to do microinverter to start, you're going to end up doing string inverter in the middle, now you're going to do central inverter, and all along you're training your crews to do new and different technologies. The conversation with labor should never be cheap labor. It's one of the biggest pieces that trips up large projects is the long-term cost of quote-unquote cheap labor. I see some faster shortcuts that are happening in the industry. You know, the horror pictures that float around the internet of bad installs. But I also caution against things like the hot deal, which is, you know, I got a container of panels here, have at it. This can sometimes interrupt the flow of standard operating procedures and can cause some other issues. And then we talk about intricate field wiring. You know, microinverters can help in some ways, but also times they can make the field wiring a little bit more complicated and a little bit more expensive. So we talk now about the service problem. Systems, from what we've studied and what we've seen, we see about a 2 cents per watt per year in long-term warranty reserve that should be put aside. Now, larger systems, that number doesn't scale linearly, but it comes down a little bit. But that hot deal that I was explaining, poor materials can lead to you know, almost doubling of the prudent warranty reserve. When we talk about systems that use remote monitoring or diagnostics, we can now bring that number way down. The figures that we've seen over the last few years of 100% optimizer installation have been phenomenal, and year after year our service costs beat our warranty reserve that we have in place, and that has led to just this side channel of revenue stream year after year that's been a great you know, great addition to the company. And on a whole, what we see on a 10K system on about a 10-year warranty is, you know, a fairly significant savings. Now that can be applied to better margin, that can be applied to better initial pricing, to marketing tactics or sales offerings that could help increase sales and revenue. All right, so I'm going to get to the point about optimizer, microinverter. I'm kind of dancing around this whole cost world. Module level cost for optimizers and smart modules in particular. We're talking about a more simplified architecture with fewer components to warrant. Larger panels can be fed into optimizers. In fact, optimizers have been scaling quite well with and keeping up with the pace of PV panel size, and then scalable architecture. So you have to sell a lot of 2 to 10 kW systems to make up for one megawatt optimizer system. So what we've seen over the last few years is the economies of scale in the manufacturing process of a microinverter have not had the same cost savings as the optimizers, especially when you talk about an AC panel versus a smart module. So they're innate into the technologies and the customer base they can prudently sell to. smart modules tend to scale better, and so we're seeing a larger cost reduction for that technology than we are for microinverters. So refocusing on the central inverter, optimizer solves the problem that micro and three-phase inverters bring, while not incurring the extra costs that that come with those two technologies. We also see better wire utilization and longer strings. So the more power, real power, we can put through a given piece of wire at a as close to the 600 or 1,000 volt that the design calls for, the more we're able to utilize that wire. Remember, voltage is cheap, amperage is expensive, and so in a system where you're pushing 500 into a 600 volt, or 800-900 into a 1,000 volt system, that wire is being utilized much higher than a microinverter system where the long trunk runs are only 240 volts on a 600 volt wire. There's a lot of extra headroom in that wire that's wasted. What we've also seen on the longer strings for the smart modules is we've been able to remove components. So I was talking about some of the NFPA requirements, especially when it comes down to disconnects at fuse combining points. We've been able to remove fuse combiners from most of our residential systems, and that has allowed us to remove the costly disconnect from the picture as well. So we've been able to remove complexity of the system by going to longer strings, by having better headroom. Most of the smart modules that are out now have 0% temperature correction. So VOC is VOC no matter where you put it in the world. And what we've seen is that allows us to turn on some of the larger residential inverters from, say, SMA. We have a very tight MPPT window. So by the time we were able to turn it on, we were overvolting before. Now we're able to get these things on, which has allowed us to remove some more costs by using a larger inverter that can that has some cost savings built into it. All right, so here's where it really gets interesting as far as the comparison between the two. We can, with a smart module, we can improve this speed and improve the bottom line of the project, either through better margin or through cost savings from the customer. With an optimizer, we're able to, across the entire company, from sales through the office into install and service, we've developed standard operating procedures across the board, no matter what size the system is. And that has been pivotal for us to be able to remove some of those imaginary balance of system costs that I mentioned earlier. We reduce some commissioning issues. Since we have visibility from day one, as the panels start going up, we can start to find all those ghosts in a system that can trouble some commissioning systems, especially when the systems are large. It seems like the larger the systems, the less visibility those systems have. In an optimizer scenario, you see it across the board. So when you put in a megawatt system, you know exactly what panel was not connected correctly, or you know which string is going to have a problem, without having to go and check each one and expel labor costs to try to find problems that may or may not exist. We have reduced our total installable part count. It seems a little counterintuitive, but with the advent of smart modules, we've been able to remove a lot of the balance of system components or shift them to pieces that are integrated into the inverter, and that has allowed some cost reductions. We've reduced our training complexities because we're now more standardized across the way, and ensures that 100% system readiness. And I mark those customers, and we've all had them, those who weren't 100% convinced that you gave them what you sold them on the contract, and now they're able to see it. Now, them being able to see it does mean that they get to see the problems if and when they arise. So one of the things that this has given us is one-trip service fix. I talk about remote monitoring and remote diagnostics. That has been the biggest key in reducing our service costs. From my desk, I can troubleshoot to a very high probability a handful of issues. stock the service truck with what parts he may or may not need, and within a very short time, the problem is identified, fixed, and the truck rolls home. You can half the amount of time it takes your service crew to fix one problem. That's a tremendous savings. And we're only able to do that with a very, very high level of granularity to the monitoring. We keep the EDCs honest. I can't tell you how fun it is to tell a power company that they have a problem with a system, and I've got data to prove it. That's always a fun conversation. But we have found a lot of power problems that have gone on for years that were affecting the customer even before the PV was installed. So through very granular monitoring, and I will point this out, most of the optimizers give you a level of data communication that is in seconds. Most of the microinverters give you that in minutes or 15-minute increments. And at that level, you're not getting the resolution you need to be able to do this remote monitoring and one-trip service fixing. And ultimately, this all comes down to lowering costs to maintain your customers, but also to gain new customers. I'm going to point out this photo here. This array, I mean, there's not much that's particularly spectacular about it, but this system is about 3.5 hours away from us. And we beat a company that was 15 minutes away from this site on price, simply because we knew that we could do a better job remotely servicing it than the local company could. And we were able to, through our standard operating procedures and our holistic approach to cost savings, was able to win the contract, even by someone who didn't have the commute limitation that we had. Many of you are going to say that, but my cost is really, or my cost of power is really only 12 cents. I can't afford to add extra components, and this kind of ties in with the title of my piece of the presentation. So when optimizers came on board in 2010, they were about on par with microinverters, and we were talking a little bit more expensive than what a base system is. As prices of panels have come down, we've seen all three have trended down, but what we have noticed is that the microinverters, factoring out any short sales or below cost sales that some of them have been participating in lately, they have not been able to get their costs down. A lot of that has to do with material count and the lack of scalability in the technology, and not being able to capitalize on manufacturing efficiencies. What we saw here this past year, and about a year ago, was that optimized systems are now less expensive than non-optimized systems. And this has to do with the better wire fill, better economies of scale on the product has reduced the additional cost much further down, and the balance of system savings. All of those weigh very, very heavily on this. So now we're able to come in and offer a better product with better visibility, with power optimization, and do that for less money. So the customer is going to get more kWh for a less install, and keep the installer honest, because we get to see and they get to see what the system's doing at any given time. And so that in turn can lead to a better relationship off the bat. Other things that help out, increase customer trust. Again, they get to see that we're involved. Increase referral sales. There's guest links that we can send off. Some of the microinverter technologies have that as well. But that has been huge at lowering our cost to acquire a customer. We're able to sell against the traditional microinverter systems, partly on price, but also on the technology and what the technology can bring to the customer. It's increased our company morale. We're able to share with the office, with sales, with the installers, data from the systems, what they're doing, how they look. Hey, you know that thing you put in a year ago? It's working beautifully. Here's the data. So it's helped the company and the employees of the company realize that what we're doing is important and special. We've decreased our service call duration. We're able to turn those around much quicker. We've increased our RMA approvals while decreasing the denials. We're able to take the data that we get and show the manufacturers, no, this is not a diode issue, there's a bad solder point, replace the panel. Or, no, the inverter is not running the way it needs to be, and here's the data why. So being able to pull that all together has definitely expedited that system, or that process. And we've improved power company quality, again, through being able to see the data and be able to keep them there. And they're always, it's always interesting. Some of them take it and believe it, and some of them will still put on their archaic monitoring systems and come back with the same data that we produce, which is kind of interesting. All right, so out of all the photos that were in this presentation, there was one phenomenon that was not in any of these pictures. And this is a nice little example of the presentation. Here's a farmette, not too far away from the office. But the one thing you won't see in this entire system and all the pictures is shading. We don't install optimizers because we're trying to, squeak a couple more panels in so I can bump the contract price up. Optimizers are for all the reasons I've given in this presentation. Shading is not one of them. Yes, they will help in the occasional scenario. Yes, they will do what they're advertised to do, but shading is something that doesn't drive us to this. It is the cost savings. It is the service savings. It is the flow and standard operating procedures that we really push to. I'm Kevin Lampo, the Design and Operations Manager of Sunline. If you have any questions, feel free to email me. It's a nice little chicken house and the manure barn that we did here in Lancaster, and it's an optimized system with no shading and beautiful orientation. But even then, we still see some things. So it's definitely a technology that I feel the industry needs to embrace in order for it to continue down the downward cost trends. Thank you.
All right, Kevin, thank you so much. That was very insightful. We appreciate it. And so now I'm sure after all the information, our audience has some questions, so we'll begin asking those. Remember, you can submit questions at any time in your GoToMeeting panel on your right. Well, we haven't heard from Sonny for a while, so why don't we start off with a question for him. Someone's wondering, certification-wise, is there a distinction between microinverters attached to the modules versus those attached to railing directly beneath the module?
There is, yes. I think in one case, if it's attached to the module, the module itself becomes an AC module, and you are required to meet the specific requirements that are at the back of the 1741 standard about AC modules. If it's attached to the railing, then the requirements are very specific for grounding and things of that nature only. There is no correlation to the module. So the module requirements or the AC module requirements don't come in. Then you're only looking at the installation or the environment it's exposed to, and making sure when it's attached to that railing, it has it's provided the proper grounding connections, because those of you who've been in the industry for a while know most of the accidents to date in the industry are related to failure of grounding one way or the other, and there are a couple of major fires that have taken place. So most of the city and county inspectors are very they're very particular about making sure the systems are grounded properly. So if it's attached to a module, you're looking at meeting AC module requirements. If it's attached only to the railing, then you're looking more along the lines of only grounding requirements and not so much of the module requirements.
All right, thanks, Sunny. Pete, here's a question for you. Are you finding that safety with AC modules, microinverters, and DC optimizers is a big hit with customers? Is it helping your sales?
Yeah, the biggest thing with the AC modules, is the monitoring and then be able to see what the panels are producing. The price of the systems are very competitive, and the installation is just very quick.
Okay, and I have a follow-up question there too, actually, kind of with the monitoring you were talking about. Someone was asking, let me find it here, the smart modules, do they have per module production monitoring? Can you monitor each panel individually? I believe you can, correct?
Yeah, you can actually on your computer hold a cursor over the panel and see what it's doing live as far as the output, the voltage, and everything.
Okay, since we gave Kevin a break here, I have another one for you. Let me just
I'm sorry, I missed that one.
Oh, that's okay. I haven't gotten to it yet, so let me pull this up here. Sorry, we're getting a lot of questions in here, which is great. Okay. Someone's asking, how is an optimizer architecture simple or more scalable than an AC module? You still have the string level limitations to design and installation and the need to transition to different technologies and equipment as you scale to larger system sizes, string, central, utility. Does that make sense?
It does. So yes, we're still talking in string scenario. However, the panels are not strung together. The optimizers are strung together. In a smart module, that's kind of confusing. When you're talking about a separate add-on piece, the panel is mounted to the optimizer in parallel, and then the optimizers are then strung together. What we've found on the 72 cell, as far as our climate, is that we've gone from strings of 11 to strings of 16. That 5 extra panels does a lot to absolve the sins of a string level architecture. And so what we've found is that has allowed us to remove some of the extra pieces. So we're coming off the roof directly with strings rather than a combiner box and then having to transition to. We're able to, on large scale systems, stretch those strings longer. So for a given combiner box, there's more panels getting attached to that combiner box, which has lowered its cost per watt down, as well as we're able to fill that wire much, much higher on a given voltage. So we're able to put more power through it without actually putting more amperage through it.
And Kevin, you can just stay on the line here. I actually have another question for you. Someone's wondering, you were saying you were using central inverters to save costs, and they're wondering if there were any other reasons, maybe besides price, for not using string inverters. Perhaps if the string inverter costs less, are there reasons for choosing between the two?
Yes. So typically, when we talk about string inverters on roof-mounted system, the string inverters are going in places that are relatively inaccessible. To that matter, we see a distinct issue with potential fire remediation, where it's better to have that down on the ground. It's also easier to service, so it does allow us to better manage what we have to bring to a particular service call. String level inverters solve a problem that doesn't exist when you're adding an optimizer. So there's no reason to have them. If the system is large enough that it would scale to a central inverter, you might as well use a central inverter. You're bringing less strings off of the roof because of a smart module. You're able to reduce some of the balance of the system, some of the complexities, and a lot of the labor necessary to put the system in, and be able to feed to an inverter that most likely has a higher conversion efficiency. And so you end up with a system that's a little bit less expensive to install. It is easier to install. It is going to have a higher performance, and it's going to have easier serviceability down the road.
All right, thank you, Kevin. I have another one here that could be for anyone. Maybe Pete, will start off with you. Someone's wondering, can the power optimizer be installed on some panels and leave others without it, depending if the shadow only affects one part of the array?
The optimizers, we actually haven't installed any optimizers, so I'll pass on that one.
All right. The short answer is yes, you can do that. However, it is better for the system to put the optimizers across the board. It is much easier to install. So any savings you're going to have with, a saving on a couple of devices, you're going to throw away in the labor and the complexity of the system. So it's not a remediation against shade. From a holistic 100% of your install, it really does reduce the cost of the system versus just a plain old generic system.
All right, sorry about that, Pete.
That's okay.
That was. Here's another one for you. Let's think. So, hold on one moment. Getting a lot of questions in. Okay, what's the impact on ROI for smart module implementation?
So all costs, well, I shouldn't say that. If we consider the cost of an optimizer to be flat to a traditional system, the ROI is going to be much higher. And Photon came out with a report as optimizers started coming up on scene. They wanted to test them in a lab, and there's a few that produce more power in an unshaded scenario. Remember that, we're talking kind of the first day scenario, but as modules age, they don't age the same way, and so the reduction in the output of power as the system ages is mitigated to a certain extent through an optimizer. So the year-to-year cash flow based on what you can expect in energy savings, and if you're in a market that has SRECs, your year-to-year stays higher for longer with an optimizer versus one that is a standard system.
There you go.
Did anyone else want to chime in on that? No? All right. I think we might have time for a couple more here. What are, both of you can kind of go, are there any differences in the monitoring capability between the optimizers and the microinverters? What about communications that are wireless?
So what we have noticed is in communications is the power line communications, so ones that transfer over the electrical wire, have limitations on how much data they can send. It's one of the reasons why we see most of the microinverter and AC module systems kind of limit themselves to about a minute is as fast as they can send data. And at that level, there's not enough granularity to data to be able to effectively troubleshoot. You can tell if a panel's dead, but you can't tell exactly why that panel's dead, or you can't tell exactly what is going on the grid to effectively troubleshoot from the seat. So when we looked at which option would we go, for Sunline, it was very important that we manage our service cost across our 6+ and growing megawatts of systems. And so the granularity of wireless versus a power line communication was very important to us.
Actually, with the AC modules, with the Solar Bridge, the technicians at Solar Bridge can actually dial in and do diagnostics on the individual panels as well.
Correct. Pete, do you know what at what interval they can do that at?
No, you'd have to talk to the technicians there at Solar Bridge, but they've been very successful in diagnosing anything that has happened to any of our systems.
All right, I think we have time for one last question. Where can the industry focus on to lower the long-term warranty reserves? Anyone can answer this. Kevin, did you want to start off with it?
Okay, I'll start. So really, when you're talking about warranty reserves, part of it has to do with partnering with the right manufacturers, those that have the right goals. I harp against the hot deal, because usually there's some strings attached, especially when you talk about a long-term scenario. Visibility of the systems, even though a lot of EPCs may be very wary of giving their customers the true visibility that a microinverter or a power optimizer might rely on or produce. It is truly imperative to reducing the long-term warranty reserves. As the industry matures and as the production is getting more and more refined of components and of the products, we are seeing that the warranty reserve is by nature going to shrink. But realistically, the more copper, the more components, the more capacitors and resistors we can get out of systems, the more likely they are going to last the 25 to 40 years that PV is touted to be able to last.
Yeah, with our systems, we found that with the 30-year production warranty from the manufacturer of the panel and the extended 32-year warranty on the inverter, we just don't have those issues.
Okay, thank you. And I know I said that was the last question, but we have one more about testing and certification. And I think we should give Sunny one more chance to speak here. So, Sunny, someone is wondering if there's been any tests confirming or denying claims that microinverters or power optimizers causing excessive heat or any kind of cell or module performance degradation?
That's more of a research project than certification. Yes, those are underway, those type of studies, and yes, the hypothesis has been that yes, it does impact. It does have a certain impact on a higher current being pulled out of the cells and the modules. It does impact the lamination and the back sheets on the EVAs to verify if they could run at those temperature with those currents and all that. So there hasn't been a confirmation that those studies are underway with Fraunhofer, with NREL, with Intertek and UL, supporting that with them. But there hasn't been a conclusion to that yet.
All right. Well, like I said, we were getting lots of questions, so I think that's all we have time for today. But I sure learned a lot, and I hope you did too. If we didn't get to your questions, I know there's a lot we didn't get to, or if you have additional ones, feel free to contact our presenters on your own. Their contact information should be on your screen. Again, this webinar will be emailed to all registrants, so you can view it again at your own convenience. And again, I'd like to thank Sunny, Pete, and Kevin for being here to share their excellent expertise with us. They did a really nice job, and we appreciate it. And also thanks to everyone in our audience for listening and asking such great questions. Your input makes for a great discussion. So I hope you enjoyed our presentation, and we invite you to join us for our upcoming Solar Power World webinars, including one that we'll have in October that will discuss operations and maintenance topics. So keep an eye out for information on that. And thanks so much, everyone.